Good morning. Oh, I think I have the auto tune on. We're doing it, designing the ClickRigs in the ClickRigs system. Nah, fuck, I'm not going to do that. I promise. Oh, I won't promise to not ever do that again. Hold on, let's turn this off. I guess I could sing a little ditty. We're designing a trophy truck for the ClickRigs system. We're doing it on the live stream and you won't want to miss them. That was terrible. All right, we're turning this off. Sorry about that. Okay, that's better. Okay. Well, that didn't go as planned. All right, good morning. We are, well, as you just heard, unfortunately, we are designing a trophy truck for the ClickRigs system on the live stream, like we do every Monday through Friday, 8 to noon Pacific time. We'll be designing other kits as well once this particular rig is done, but that's what we're working on right now. So, let's see. Where were we at? So I think this I believe is part 4. So I think yesterday, part 3, we left off. We had just, I believe, kind of wrapped up a lot of the rear suspension, the triangulated 4-link, and that was printing when we left, and so it printed, and I have installed it. Let's so you can kind of see we've got that set up, and I'm pretty happy with it overall. I think it's going to be good. There are a couple probably little things I would like to do. These single link pin connections, they work pretty well, but you can make them stronger by kind of spanning the entire axle and picking up the 3 points top and bottom. There's a heavy duty secret facility HD upgrade kit, and you can kind of see sort of all these black components there, and then similar this brace. And so what I might do, I'm probably going to include this brace, which also lets us run the limit straps, which make these things a lot more controlled. So let's jump into the browser here. Okay. Let's go ahead and throw those components into the assembly as we go. And then we had also kind of started really roughing out the body here. And this right now is in a super rough state, but generally speaking, kind of using the Chenoweth Millennium buggy, which kind of came out, I believe, sort of near the end of Chenoweth's existence. But I remember when it came out, and I thought it was pretty badass looking, and so I'm kind of picking up some design cues from that. This, unlike the Mayday rig, this TBRD01 for Thorne Buckingham is going to be a single seater, and so I really kind of liked the like semi-rounded side pod design of the Millennium buggy from Chenoweth, and this is probably too round, but again, just kind of roughing out some concept shapes. But let's go and let's throw in some of the HD components. I'm also gonna, I think, replace this one with the heavy duty one as well. So I'm gonna bring in, run the model catalog. I'm just gonna go down and see if I can find that existing part. think that's it. Yep. And then the axle brace. Let's mate these up. We're going to use the fasten mate. Let's do it off the front here. Flip that. And same for here. Flip that one and rotate that. Nice. And so those are just stronger parts, and those will help the connection stay together. Although we are probably going to have to actually flip that around, because on this one, because it's a little narrower, the trailing arm gets in the way of the, you can see that it gets in the way of the limit strap connection. So let's just go into that, and we'll run those off the back, which will be fine. Perfect. And then we're leaving these three connection points free, so that kind of once we wrap this up, we'll design a display stand that will also allow you to store this in a way that takes the load off of the TPU springs. That way they don't creep over time. You know, if they do, they'll kind of sag out. Basically, if you leave it stored on the on its wheels, compressed under its own weight, over time those springs will sag. But if you lift it back up and store it unloaded or in full droop after like a day or so, those will sort of restore themselves. But if you can, when you're not using it, if you can store it with the suspension unloaded on a nice stand, I think that's the way to go. So we will make a stand to go with this one. Okay, so the other, let's see, the other thing I was playing with is I'd kind of taken this cab and tail section from, it's the Mayday cab and tail section, and so I was just kind of playing around with, we're not going to use this cab, we're going to do a different one, but just to sort of illustrate how you can kind of mix and match parts as well. Like this whole setup, we'd have to, it's not totally set up, but you could put snap studs in there. And so, you know, this could work. You could run this as is, and you do a little hood. I mean, I guess if you wanted to, you could kind of run like the Earl Motors hood, although we'd have to do some cutouts for clearance because this has much more travel, but you know, that's kind of cool. So you can kind of mix and match parts and create things. But in playing with that, I did want to kind of had a thought, might use a similar style tail section, but what's interesting, because this one you can kind of see is a fair bit shorter. If we use the same length tail, we can actually, instead of mounting the spare tire on top like this, I'm curious if we can kind of flip it around underneath so that you know, we can keep that weight back there but keep a lower center of gravity. So I just had that thought right before we started, so I kind of want to see if we can make that work. I'm just gonna And if that works, what we can do is we'll basically take this tail section and kind of modify it for the new rig. And also, we talked a little bit about it yesterday, but when we were looking at that Millennium buggy from Chenoweth as inspiration, it had a little rear wing, which in some ways is probably kind of ridiculous, but I sort of liked it. So that would also let us maybe design this tail section with a little rear wing and have the spare tire tucked underneath it, kind of like in the Millennium buggy, which would be pretty cool. So does that clear? Oh yeah. And so let's see if we bottom out. Yeah, so we can fully slam this thing down and the spare tire still clears. So I think I'm gonna try going that route and see what that gets us. So maybe we'll kind of leave the cab a little bit as it is for now. And that's low. We could bump it up one, but I'm just going to bring in that tail section as well, just to kind of have it as a reference. I'm just going to mate it real quick to the tab, or to the cab, I mean. Maybe add in a couple more of the pieces. Spare tire peg. Again, we can hold shift, we select this face. We really want that mate connector in the center of that square, but when we move over it disappears. So on the face, hold down shift. Now we can select it and we can probably do a little better than that. I mean, it's good enough for what we're doing right now, but let's pick some new. If we use that one. It's pretty good. It's close enough. And then let's just grab ourselves a wheel assembly, copy that, and this might not be quite correct, but it's pretty close. And then I'm just going to do another quick mate. Okay, so yeah, it's kind of coming along. Let's see. So we've got a couple options here. Let's just gonna suppress this mate real quick. So this version right here is you know, we've got the cab slammed pretty low. We could also bring it up 5. So it kind of sits right on top. Which would let us bring a hood out with a little more clearance. I do kind of want it to be a little more low slung than the Mayday rig, so let's see. How tall is this cab now? 25. Let's find the Mayday cab. So that one's 20. So we could bump, basically, if we bring it down 5 with this cab, we're at the same overall top of the cab height as the Mayday cab. But if we go up one connector layer, and again, this cab is super rough, so let's see. And then if we made this section 10 instead of 15, what does that look like? I don't think it looks quite as good, but let's see. And then this. So it's almost a little too pancake-like. I kind of actually liked it the other way, so let's. The other way we could go about this, let's do this. Maybe it's just proportion. So we can go that 10, but then this one, we could, instead of doing that 10, we could do that 5. And see what that looks like. And then this would all be that's probably also a little bit too low for our spare tire to clear. So we are going to have to go back up. So let's right now I'm just trying to basically rough out where is the cab going to sit. And so it would be the other thing too, we have to think about printing this. So if we slam the cab down and do a cutout like we've been talking about, all of that is going to be an overhang, which we could maybe go print it vertically. Which could be interesting. Really just depends. So let's see. Proportionally, I don't think that's too bad. We basically are, you know, the ClickRigs layer system needs to work in increments of 5 millimeters. The chassis components are 1 centimeter. The connector components are 5 millimeters. And so if we keep kind of everything that stacks up in those increments, with the exception of like caps, which sort of stop your ability to build up or down, intentionally so, then if we stick to those increments, you know, you could stack things over here and stack things over here, and then they'll line up, so you can kind of create all kinds of different things. Let's see. We will need to create some clearance in there for that. But I think we'll work off this tail section. We'll kind of bring these lines out to match that up. The other thing I would like to do is kind of tie like a support structure from somewhere down in here out to here, just to kind of triangulate that. And I think we can probably extend this cap and then do a piece that kind of connects there somehow. We've got this snap dot connector. Maybe we could add one in. I'm just thinking through here. And this might be a good use for the edit in context. And to do that, I think, okay, this is probably what I'm going to do. I'm going to go into truck layout. And let's turn on our chassis layout. I'm going to show all the parts here real quick. Just kind of And so I think just trying to figure out how to do this, if I bring in the tail section into here, drive it in, then I can go into the assembly, add it in there, and then edit it in context, maybe? Let's try it. I think we're already lined up. Now I'll insert that from the current document. I think. which is interesting. So just gonna fix this real quick, and then I'm gonna remake this. Interesting. Oh, close enough. Just want to make sure the tire is going to clear at that length. Perfect. That looks kind of cool too. That'll actually be a little bit flatter. Let me hide this real quick. And so that's where it would come in. Let's see. So that's kind of this setup right here. That's set up to line up with the end of that. So that would be in the same position. And yeah, it just tucks in there, which is perfect. I like that a lot. Okay, so let's see, and how so that's a weird height, so obviously that, let's unfix this. And so now I'm trying to think if there's a good, I could insert connector pieces here. I wonder if there's a mate that just kind of lets us type in an offset. I mean, just fasten, do that. It's got offsets, so if I made it to here and to here, let's do some offsets. Yes, X, Y, Z. So in the X, we want to go -10, I believe. Yep. And let's see, what are we height-wise? Because that's what we want to match. From that, we are 25 up. That's going to be in the Z. Cool. I'm just going to name that mate real quick because it's an anomaly because I am not using other components. So we'll just call that temp tail mate. That way I can go in later and delete it and reference it to the final components that are coming in. So basically that puts this tail component right where we're going to want it when it connects up with whatever the cab ends up being and where everything else is. So I think now what we can do is go in and do an edit in context. And what I'd like to do is figure out a way to bring a support brace kind of up to here that can just kind of basically sneak in between this whole triangulated 4-link setup. Because that is something else that this particular one, it's got all this weight and it's cantilevered way off this section. So sometimes when you do a big crash, it's like well, now it's not doing it, but this this tail section basically can snap off. Takes quite a bit, but again, the whole goal of the Thorne Buckingham trophy truck design is the least amount of damage in a crash possible, and so, which will also make it probably more fun for smaller children to play with, because they tend to not be super gentle on things and get frustrated when they have to constantly be putting the thing back together. So this one should be in some ways both more advanced because of the design and less advanced in terms of the patience and skill level required to play with it and have fun. Okay, so we've mated this in our assembly in the position that we want, and then I think we can do a in context design to make some new parts and modify this. But first, I think let's do something before we jump into that, because it can get visually a little distracting. I think we're going to want to bring out this connector so that we have something to connect to. So we can probably just make that, which means we reuse this one. This actually is a component from the Earl Motors Baja Race Commando kit. So we'll end up needing to modify this and make a new part, but that's okay. That is the beauty of using additive manufacturing, is that we can very easily add a new component whenever we need to. And it's essentially, the extra cost is just design time, design and prototyping time. I almost wonder if we want to bring out both of these. I don't think that would be a clearance issue. And that'll let us have two connectors there, and then we can kind of bring it up into one. And I'm almost thinking about doing something like kind of like a single link built in this sort of a style where it's a flexible TPU beam with a stiffener snapped on, and then kind of a flexible connection point to sort of create like almost like a tube brace. I sort of do that in the Flying Pancake long travel kit. So we actually use the triangle brace from the Mayday trophy truck as a cab brace. Let me pull that up and show you. Yeah, so here. And so these components are actually just like these two things here are just the triangle brace. And we use it, instead of a moving link, we use it as like a tubular kind of roll cage structure to brace this chassis to the cab. And so you can kind of see we tie into these front fender mount points and then do a single point at the top of the cab. And I don't think we'll do it as a triangle, but we could essentially make straight a single beam version of those and connect there to there and kind of brace that whole thing. I think that would be kind of a fun way to do it. And then also will let us print those components flat and then get that angled connection. And the other upside too is that then becomes kind of an interesting, just a sort of a generic sort of tubular brace that you could use and all kinds of other things when you're building some new creations. So let's go ahead. I've just been doing a lot of talk, not a lot of CAD, but sometimes that's how the design process goes. It's actually very helpful to be doing this on a live stream because it lets me sort of talk it out loud with myself, which I sort of do anyway, but this just normalizes it. Let's see. So I think I'm going to go into the component generator, and I'm going to make this. And so if we do that, that is going to, that will make this part asymmetric, so we'll need a left and a right. I think that's okay. Again, doesn't hurt us at all to add some new parts. It's just a little bit of design time. I just have to make sure that I do it. So let's jump over into the component generator, and we're going to make a connector. And we're just going to copy this to the clipboard. I'm going to jump into here, and we're going to paste that tab in. And we're just going to rename this. I'm calling it the trailing arm pin skid plate. I'll know what it is. Once this goes into production, it'll get a part number, and you can very quickly realize that trying to come up with meaningful part names for everything that everyone will understand is an almost impossible task. So I found it's just best to name it something that you will understand within the context of that design session or sessions, and then just assign a dumb part number thereafter and have a good catalog so you can find those components. And actually, I messed that up anyway. We do not want a connector, we want a cap. Let's go back to the component generator. We're going to make a cap. Go into the cap template, and we're going to copy that to the clipboard. And we're going to paste that tab. And we're going to rename that, and trailing arm pin. See, I have no idea if that's what I actually just named the other one, so it could be different. Maybe it's the same, but it's probably close enough that I'll know what it means. Let's turn on a couple of sketches. We don't want the pattern master, we want the layout pattern, which is this thing. And we want the connector layout sketch, which is actually what drives our geometry. I'm just gonna delete that. Maybe. Okay, so trying to remember what the what that one looked like. So it's a 2x3 with a single pin, and then what we're actually going to make it is a 2x5 with an outboard pin coming off the 2 position. So we're just selecting, and this is just a little component generator that I built. There might be a 2 position, I believe. And actually we just want it 3x4, I'm pretty sure. Because the 3x5 ended it there, and we just want these 2 extra. Perfect. I think that's good. So yeah, this is just a model that I built that kind of pre-does some of the stuff for you. You can kind of see how this works. We just can sort of pre-select these connectors. Helps if you don't hit a key before you've hit use. At some point I'd like to play with feature script and try to like automate a lot more of this. So that kind of gets us the standard ClickRigs systems connections, and then we can just go in and draw lines in between. And so notice we're just putting lines in between these nodes, and that closes the sketch. And so that should be good there. Then we can close the layout pattern because we don't need it anymore. And as you can see, we've got a lot of red stuff, which means we broke everything, but that's okay. We just basically now we just go in and fix it. I'm not sure if there's a way to multi-select. It'd be nice if there was in these, but anyway. And just kind of get our base. We're selecting all of these sketch features. That's good. Now we're going to do the snaps. Onshape I know just came out with something called like a query selector variable, which I haven't really thought it through, but there might be some use for that in sort of automating some of this stuff without using feature script. So we'll see. It's still much nicer than doing all this from scratch. Now we're just putting the peel flange on, which is just a little lip that when you're playing with the components makes them easier to pull apart. this feature here is just, I really should make this template with like one element, so there's a lot less to delete, a lot fewer broken things to delete out of there. Pretty sure I can turn this sketch off now. Because this is the top top surface of the print, we just kind of try to break up any large flat areas and just kind of, I think, makes it more, the surface quality more aesthetically pleasing. So kind of bump those in by one layer. And then kind of do some offsetting. And choose the offset tool. And I kind of offset this by 2 wall thicknesses. This helps the print quality stay nice and clean. Let's go. And then, so basically we're going to just kind of extrude down this section. We can probably do it as it is. Yeah. So there we go. And that'll just be, just kind of breaks up the print a little bit. And so I think that's probably good. And you know, we're just gonna save ourselves some trouble. We're gonna just mirror this part. Gonna mirror it there, but we're gonna make it a new part. So I think that's, and then let's go into our assembly. And we're going to replace these 2 components with our new one that we just designed. And we'll do a fasten mate. Here. Yep. And then similar, doesn't really matter which one we use. Cool. And so now what that does, that gives us these 2 extra pickup points for our tail brace. if we need them. I mean, we might also, I could just be totally, because if we do the flexible connection point, we could probably just pick up right into there, which would be cleaner. I'm going to keep these parts in the back burner, but let's keep these parts here for now, and maybe we'll just sneak a little flexible nub right into there. Let's see what happens when we edit this in context. Okay, so you can kind of see we've I'm going to hide other parts. Now you can kind of see this sort of translucent part of the model is actually our prototype assembly. And then this is the part we're editing. I'm pretty sure we can add new parts in this setup as well. I don't do a lot of in-context stuff, but it's a pretty powerful tool. I'm not super familiar with it, so we're figuring it out live. But we can now reference things off of this assembly. And so I think, unlike what we did for the foldable ARM front end, we designed that one essentially flat and then cut it up and then reassembled it in its folded state. Here I think we're going to design this in the folded state and then cut it up, or design it as 3 separate components and then flatten it out. It's probably how we'll have to go about doing that. Again, the CAD is not great at designing sort of compliant or bendable components and kind of simulating that. So we kind of use a number of tricks to sort of hack that system to get what we want. So what we're trying to do right now is we are trying to design a link that picks up this point right here, flexes, and then we'll pick up some kind of point back here to brace this to the cab, which we don't see right now, so that this cantilevered rear tire weight is better supported. And we need that brace to kind of sneak in right here, in between the trailing arm and the upper triangulated link. So let's see. Maybe we start by adding, I guess we could pick up this center bit. Could pick up this snap connector here and do it as a triangulated. Question is, will that clear? Let's jump over into this real quick. Gonna move that into the full bump position. So the question is, do we have room right in here to sneak a connector and then sneak from there down into there? I actually think we do. which is just, it's kind of wild. That won't hit. Okay, so we're just thinking through some of this design stuff here. We're like an hour in and we've hardly gotten anything done, but that's okay. We're working through some neat stuff here. Let's jump back into did that just okay, so let's go back to edit in context. So I feel like we need a plane. From here through to here. So I'm just going to do a new, let's go top. I'm just going to do a new sketch here. I'm just going to pick up that point. Doesn't really matter where. I'm going to pick up that point. Just going to do a line in between them. And I create a plane. Right there. And then we'll do a new sketch on this plane. And what we want to pick up is, I think, what happens if we just, does that project in any usable way? Oh, look at that, it does. What about, so we're picking up that. Okay, so we've got this plane. We're trying to design a brace that's going to go from here to there, and it's because it's going to have bendable, flexible end components. We're modeling it in its bent state, and then we are going to flatten it later. Okay, this lets us hide some stuff. That's what we wanted to do. Cool. Okay, so sorry, just hiding that. Let's go back into this sketch. Again, we're editing in context. I don't know what in the hell I'm doing with edit in context, so bear with me. What if we project that? What does that give us? Perfect. So now we can kind of see here roughly. So that line is kind of where our brace would go. The question is, can we get it to let's just do a quick and dirty sort of extrusion. I don't know why we keep jumping to an arc. Let's just say this is roughly 2, 4 maybe. And we're just gonna extrude, and we'll go 1.5 in each direction. Oh. And so we're just kind of getting a rough sense. Let's if this isn't what the brace is going to look like, but it'll be roughly this size. And I just kind of want to see where we have interference. Yeah, if we go to the center, let's just say that's there. Does that automatically insert it for us? Kind of fix this temporarily. Actually, let's go back to the edit in context. Yeah, so we're gonna have to come outboard with that. We're not gonna be able to do that in the center. So let's go. Let's see what happens. So we just adjust our plane sketch. Let's get rid of that relation. And we can kind of drag this. Let's just say we're gonna do it somewhere there. And so that again, this is just a really rough approximation. What I'm trying to do is sneak this brace from this position to support this tail section, but clear this triangulated link. So a lot of this is just packaging. And so as we cycle, that, we're going to have to clear that, which I think means we're going to have to go wider, or we have to come back out. So that's the other thing. We probably, that's probably why I originally had that. So let's re-edit this in context. Go back to context 1. Oh, hey. How you doing? Let's see. It is a tricky for sure. Is that bend it till it clears kind of thing, or can you capture the extreme points somehow? I can. So I'm using the edit in context feature here, and so this is kind of the assembly, and it will show the articulation and however I have it at the moment in the assembly. And what I'm just trying to do is just kind of visualize a path to sneak that brace through. And I think I just need to bump that back out. So, and then this this brace is actually going to be a flexible component, kind of like this triangulated brace here. So it'll be a TPU with a rigid stiffener, and so it'll actually bend kind of here and here. But I'm going to model it in the bent configuration, and then just split the components, and then unbend it into a flat pattern for printing. And so I think what I need to do right now is this is just too close. It'd be nice if I could have tucked it right in there, but I think I have to come out one snap grid past just to get a little bit more outboard of this triangulated link. So I've got this plane, that one in the sketch, and I kind of had picked up that point. We're going to delete this relation as well. And I can actually show my grid. So let's show the grid pattern here, and then I'm just gonna connect it to there, and I'll bring a bottom connector out, which I had already just made, and then for some reason determined that maybe I didn't have to. But and then this not sure what that one. So, and then this, there we go. Oh, it was on a midpoint. So I actually want it on that, but so I can kind of drag this around to kind of see where I want to bring it in. So right now I'm just super roughing stuff out. This can actually go back there. And this line, this sketch right now is just defining my plane. So I'm moving my plane around. And then let's see, that sketch. Will now be there. Let's view this normal, the sketch plane. So does that kind of get me what I want? A lot closer. Let's go to the assembly. You know, if we go to this, what we're trying to do, I'm basically using this tail section right here off of the Mayday rig, and just trying to, this works pretty well, but in a big crash, this tail section will fly off because it's obviously super cantilevered. But you want to be able to hang a lot of weight out behind the rear axle. And so what I'm trying to do is just essentially sneak a link kind of from there to there to brace it. And then I'll modify the tail section, but kind of basing it off that one. And then this is the kind of the current state of the new design. Yeah, the master grid helps, and it's kind of one of the things that you know, lets all of these components become a modular system, so that, you know, we've got fixed 1 centimeter and 5 millimeter stack heights that you can build up or down off of the main chassis components, and then everything is in a 10 millimeter by 10 millimeter grid. And so as long as all the parts are designed kind of like conformed to that grid, they can be mixed and matched, and you can build all kinds of different stuff with the parts. So yeah, if we extend those connectors out, we're good. And bump, it's just droop, I think, that we have to worry about. That's about the limit. So we're really close there. I bet you that'll clear, because this doesn't probably need to be 4. Let's see, this one's pretty good. What is that? That's like 5, but we could do a little boop out there and just bring this a little wider. So if we go back to the context, thanks, glad it looks good. It's always hard to tell what it looks like over the stream, but and in case you're wondering, we get kind of a fancy. There's a there's an overhead light as well, and then so I'm using the iPad version of the Stream Deck to kind of trigger different lighting scenarios when I switch to kind of the different. So it's like we can kind of go face, overhead, and then the lights kind of change, and then I have an overhead close, which will kind of come in and give a little bit of a close-up. Yeah, that's and basically what that does is there's an overhead light as well, and it just turns that on and off. It's probably overly fancy, but I had fun setting it up. Okay, so I think we can sneak that in if we come out one, which let's go. I already made little parts, so we're gonna put these parts back in and delete those. We'll insert the parts that I just made. And we'll mate those. Pretty sure that's the one. I'm just using a fastened mate here. Flip that into those nubs. So basically it's this same part, I just made them, but it gives us the ability to come out to that point. Right there. You know what I might do, just so we have those, I'm going to get those printing. So, and these parts they are not symmetric, so they're mirrored. So we'll grab both of these. We will export them, step file. Let OnShape think. Save those, don't really care what they're named. We're going to jump into the slicer. And as usual, these parts are all good. So this is kind of the collection of new parts that we've been making for this kit. I'll just drag over the and so we're replacing these. So we can delete these out of it. I just kind of like to, I sort of use the slicer as a, a collection bin for all of the new parts in the kit. That way, kind of at the end of it, I can just print out the whole assembly. But for now, let's bring in our new one. And we're going to change the filament, split to objects. Auto, and then we've got our presets. Slice the plate, and we'll do that on 0B. No need for any of that. Cool. Let's go back to the browser. And into the CAD. And we'll continue the saga of sneaking this brace in. And so what this initial little study did is I think it showed us we can kind of make it fit. but I think we're going to need to come outboard one good step. And I think if we do that, we can make it work. So let's just let's see. Let's go in here, let's do a new sketch. Let's use those. What's interesting is that doesn't conform, but I'm pretty sure that was added for a bump stop, and so that's positioned where the axle hits. That's not true in the case of this new one, but we'll just leave that in there. Let's see. You know, it might be nice though, is I think. So we're gonna make kind of an outboard landing pad so that this brace, and the brace won't look like this. This is just a rough concept. We're gonna add outboard landing pad so we can bring these out a little bit more so that it will clear our upper triangulated link when we're in full droop. So we're just kind of sneaking a brace in there. So we're gonna bump this outboard and then create a spot for it to connect to. But it'd be nice if we adhered to our vertical system, which I think would be, what does that give us? This distance to this distance, so 35 millimeters. Let's see if the edit in context kind of gives us that. Yep. So the sketch, actually want it to be there. And so now what we're going to do is we'll use these, bring those in, and we're just going to create kind of some outboard bosses. Let's hide the other sketches just to clean this up a little bit. Make those construction. Let's see, in theory too, this should be on the grid. Yep, 10 and 20, good. And so let's extrude that. We're going to add it. That, and we're going to it's going to be 5 millimeters. It's going to be the other way. And so that gets us pretty close. This probably will look horrible, but go in and mess with that a little bit, but for now, I think that's not terrible. I'm going to hide this plane for a second. I feel like I'm in a constant love-hate relationship with planes. They're useful. They're kind of annoying to have to make. And then visually, they're always cluttering everything up. But when you need a plane, you need a plane. That's just the way of things. And we're going to pick that up on the bottom. That'll be interesting. So let's go to the assembly here. So we get kind of these bump outs. Again, just kind of roughed in. We're going to put a snap dot pocket here. Let's just go ahead and do that now. Hide this for now. And let's see, do I have a plug? I don't think I do. Yeah, there's all the ball link plugs. So we're going to derive in our snap dot plug, which we should have in the current studio. And that is going to be printed to the top. So that's the plug we want. Essentially, to do all the geometry. So the geometry for basically the pockets that you put the TPU snap dots get pressed into. I just use forms. So the ClickRigs system I model with a lot of forms that are dialed and tested, and then I just can move them into place wherever they're needed and do a Boolean to remove that volume. We're just going to transform this by make connectors. And then we'll do another one and we'll copy it. Also by make connectors. And then subtract. In this case, I don't think we need to keep the tools. Actually, we might as well, so that they're just in this model. It's being persnickety. There we go. That's our target. And then for now, we can just hide these. And so that's what I was worried about a little bit. We're going to have probably some clearance issues there. It's going to go outboard. So I think what I might do is just this. Let's see if this works. Cool. Kind of like that. So now we've kind of got a landing pad there, and that'll be a little more outboard. Get rid of our clearance issue there. We'll bring it in there. So let's jump back into context. And before I jump into this, I'm going to go take a short break, and I'll be right back. You can watch, jump into intermission, and you can watch the 3D print finish up. Be right back. Alright, we are back. Let's see. So, I just made these sort of outrigger snap-dot pockets, and we are in these extended kind of bottom components, and we're gonna, now we're in context, and we're going to kind of make a plane and connect these bits. So let's actually hide this, because that's just a artifact of kind of figuring out what we need to do. Let's see. We'll begrudgingly show our plane again. As far as I know, I don't think that OnShape, I haven't checked all the new stuff in a while, but I don't think it has 3D sketching. Let's check. Yeah. We'll just work with our plane here. Actually, I don't need that circle. So now that should be our plane. And let's just draw a reference line. Just a new sketch. And project that. And project that. So that kind of gives roughly, I think, what we want there. And now we're just going to go in and we're going to model sort of what the actual connectors are going to look like. And again, this is going to be, I'm going to model it in the bent state and then combine those parts into a flat state, which is sort of the opposite. I can actually go in, we'll just do a little recap here. Let's go back to the truck layout out of context and show, let's just show all the parts. And so we've got a couple things we're showing. Let's isolate this one. So this whole front ARM assembly is all done out of one printed piece that gets folded up. And so it's kind of shown in a couple states here. But if we isolate that part. That's what the flat printed component looks like. And then, you know, these are all your flexible joints. And so this whole thing gets folded up into a lower A-arm, upper A-arm, and an upright assembly. So this one I actually modeled and designed flat just because I had a good sort of mental image of how everything needed to be. So I was able to just design it flat and then fold it up into, you know, I kind of made a secondary part studio, and I took this in, and we can kind of jump backwards in time here. So just to kind of walk everyone through what I did. Let's hide that because it's not relevant. So I brought this part in, I designed it in the other studio flat, and then I brought it in, and then essentially I just used the split tool and split it up into, you know, separate components. And then at that point I was able to take those separate components into the assembly, and then, whoa, apparently we broke everything. Fascinating. What did we do? Sometimes that happens. Wild. Okay. Apparently we've put it in a folded up state so it can go on an aircraft carrier or something. That actually looks kind of cool, but I don't know what happened there. So we can kind of go into our little history. There has to be a point in time where this was assembled correctly. Okay, so we're good there. What happened? That was at 10:12 today, so that was only like half an hour ago. Over there. Still good. Interesting. Okay, I think. What about there? I'm just trying to figure out what changed. I don't use the versioning a whole lot. I'm more like in favor of the hack, make a copy of it and hack away at it, and then go back in and just kind of manually factor your changes back in. But let's see what I do. Replace with. All right, well, let's just do that. See what happens. Oh, all right. This is all just a misunderstanding. The joys of everything being interconnected. Sometimes it's so convenient, and sometimes it bites you in the ass. So this is an instance of being just kind of completely dumb. I rolled back this tree so that we could talk through something, and then I tried jumping into the assembly. But that assembly now was pulling from this model in its rolled back state, which is hilarious. So all of that was for nothing. But we'll just continue on. So this was in the flat state, split it up into components like so, and then did some transforms and was able to essentially reconnect it there. And then in the assembly, these are just essentially revolute mates at these corners so that it can be cycled. And then that is something I forgot I did, which was I added this piece in, so let's just mate that real quick. And so now those components can cycle. But the point of all that was these I modeled in the flat state and then altered to put them into the bent in use state. I could have done it the other way. I could have modeled them like this, split it up, and then flattened it. And that is what we're going to do for this brace. So sort of the opposite of what we did for the front A-arm assembly. We're going to model this in its in use state, and then we're going to flatten it for printing. And so I think the first thing I want to do is a sketch here. And then we're going to do the tab. We're going to kind of use this plane. Do I have that line? Or did when I rolled back the context. So here's what we're going to do. We're going to do edit in context. I might have to redo that little sketch line on that plane. Yep. we have that. Yep, now we have it. I could keep editing that in context, but I generally don't like the visual clutter of all the assembly stuff in there, so I kind of use it to get some reference components and then just sort of jump back into, I think we probably still have that sketch there. And so now I'm designing the little tab that will be connected here. And so let's see, it's a 4mm hole. And then the flat end of it needs to be perpendicular. Let's do that. I think I need to tweak this plane though. I figured as much. But that's okay, we can just sort of cheat it. I think that will get us to where we need to be. Let's find out. So freaking close. Oh, hey, let's see who we have. Hey, Rob Eagle. I don't know if you're still here. I just saw the comment, but thanks. Awesome that you got the rigs, and yeah, I can't. Let me know what you think of them, and yeah, follow along. These are long, and I know it's not the best time. It's the time of day that's good for me, but it's not the best time of day to watch these live for probably like dads and moms and kids. But these do get saved to YouTube, so if you feel so inclined, you can watch the many hours of design time that will be going into these rigs. I think I'm also going to link kind of the streamed series for each rig on the product page. So it's kind of like, hey, do you want to watch 40 hours of video about how this particular kit was designed? Have at it. I'm also planning on cutting these down to kind of into like a 5-minute sort of highlight reel as well for people who don't have quite as much obsession or time. But yeah, so I don't know where you jumped in, but we're designing a new rig to kind of a competitor to the Mayday trophy truck kit, which you may or may not have. But I kind of wanted a rig to compete with this, so that's what it's very similar layout, but this new one is going to be, I guess, a lot more crash resistant. The Mayday kit is one of our more complicated ones, and it holds up well, but if you have a big crash, parts will go flying, and that's intentional. It's sort of designed to simulate crash damage. But this one will be a little bit more robust, while hopefully having similar or perhaps better performance. So we'll find out. But that's what we're working on now. Let's see, and then go back to the browser. and we are, that's kind of where we're at with it. And I'm trying to design a brace for this tail section right here. So this orange thing is just a rough approximation. So I'm trying to bring a support brace from here up into there. And so that's what we're doing. And kind of, that's, again, this is also super rough, but that's kind of roughly what the cab will be like. Just picking up a dimension here real quick. Yeah. And so we'll go back into the sketch. I'll just make these tangent. So we're just kind of right now we're just designing the little tab, although that doesn't. Mirror that. And we're going to give this a relation that's perpendicular, which is that's why. Sometimes these automatically added relations are kind of annoying. And the idea here is that, that's right, because that's not centered. That's all right. Or just kind of, again, roughing this concept out, and then so what we can do is we can extrude that as a new piece. It's going to be 0.8 millimeters, which is essentially 4 layer lines thick, because that's the thickness that we use for the flexible TPU bits. I'm just going to change this color to the green so that we know it's TPU. I generally use sort of in the design phase color as a way to designate what the material is going to be. Nice, yeah. It's potentially good background noise while designing. Design background noise while you're doing designing. It's many layers there. So we've got that, and then that. I'm kind of working through concept here. I haven't made a brace like this before, so it's going to be a lot of me staring in a befuddled manner at the screen while I think. It's probably good. This will be flexible, just so we can kind of get the printer flat, but get the angle. But this part doesn't articulate, so it won't be moving. So we don't really need a ton of material there for that. And let's see, we can probably jump in and do this component. Go to the assembly. I also don't like that, but we'll deal with that later. Let's figure out this bracing issue. I think when we restored this, that got moved. So I don't know if do I want that to be 30? Let's hide this. That's better. It's 25. I'm curious what the Mayday rig one is again, because I like those proportions. Yeah, so I think something like that. Let's just create a new context here. And I'm going to create a new sketch just to see if I can get that sketch, or a new plane, just to see if I can get that. Oh, you know, let's just use that for now. There's probably an easier way to do this, but go. Yeah, this has been a lot of back and forth today, and a lot of just watching me stare seemingly mindlessly at the screen, but that's not what's going on, I promise. Let's jump back. Just do a new sketch here. Alright, so now we've kind of got our two pieces. Can we draw that on I don't know if that'll work, but let's just try it. Interesting. Okay, so let's... We need that to be a consistent thickness. Let's make that perpendicular. We're just going to pick this one. I think my internet connection is slowing down. Okay, let's just do this blind for now. Let's call it 2. I'll call it 2, because I think we want to go 4 there. We've got a little bit of leeway in this design. Let's go to assembly. Although that's a little weird that we don't have those parts. What if we just insert them? that's kind of roughly where that would go. Okay, this has kind of been a pain in the ass, if I'm being honest, but that's okay. We're going to figure this out, and we're going to add this sort of method of design into our toolkit, because I think once I kind of get this process of making these sort of flexibly connected brace elements down, I'll probably use them in a lot of places on these kits, because it kind of opens up a lot of interesting possibilities that would be very difficult to manufacture with the printers otherwise. And also I think it'll look pretty cool because, you know, in theory we could build quite elaborate space frames using this rigid material and flexible material concept. So sort of like, you know, these trailing arms, or these basically like a suspension link, but there's no reason we couldn't do little straight links and build, you know, neat triangulated truss and space frame structures. So it's worth figuring out, and it'll be, I think, really awesome on this kit. It'll definitely be sort of one of the distinguishing features that sets it apart from the Mayday kit. So it's just a little tedious, and I'm not sure I'm even doing this the best way. What I might do kind of after this is a little bit of reading, watch some videos, and see if there's kind of a better way to approach this. And if anybody has a thought on the best way to kind of like make connectors between two elements in an assembly in sort of 3D space without, as far as I know, it Onshape does not have 3D sketching. Yeah, and I'm pretty sure I'm on the right track, essentially just editing this in context, creating a plane, you know, from this direction between them, and then using that. So I think this is pretty close. I think just what's happening is that whole element got shifted. But do we still have these parts if we jump back in? Yes, we do. So let's make a couple tweaks here. I don't know what's driving this. That's better. I'm just going to redraw this one because it's not perpendicular to this plane. So we're going to go in and we're going to just do a new one. It's not that hard to do. I mean, how we can even, let's just do it properly. one, I will extrude that. Not as a surface. New. Cool. And so one of the issues I'm kind of running into here is, I'm designing it in the bent up state. The issue is that, I want this to be a consistent thickness, but we're not really going to model in kind of the flexible kind of bent joint. I guess we could. So maybe we do that. Maybe we can just kind of do that now, and then split it up later. Can we delete that? No. Oh, that's the one we wanted to edit anyway, so. probably roughly what it's going to look like there. See if it likes that. Can I delete that? What if I insert our new one-piece deal? What if I made it cool? That's kind of roughly what that would be like, and then we can use this this sort of in use designed in the bent state part to get some like basically just some rough lengths. I do think though I will just go in and get, we don't need those fillets. Very cool. And then this will, let's see, we can kind of do the thickened up part. I might as well just design that, and then the I bet you there's another way we can do that. Okay, so you know what we should do? Let's get this tail section printing, because we're going to need that. So let's just export that now. Should have been printing that a little while ago, but I think we got it like an hour and something. We'll see how long this takes, but we might be able to get this part. We might be able to get the tail section and a couple of these links printed before the end of the stream today. But this one's going to take a little bit, so if we want any chance of doing that, we're going to have to get that one going now. Come on, Onshape. There we go. I'm probably going to be 2 of these. But let's jump over into the slicer. So we're using these components. We're going to bring in this one. All our settings are right. Slice that up. All right, it says 35 minutes. That should be plenty. Let's let's pull these components off. These are our 2 new little bottom plates that we designed. Throw those on in a second. Get that printing. Awesome. All right, let's jump into the overhead here and we'll just swap these parts out. Put a little boo-boo on there. It's alright. Probably because I was touching the build plate. Got some finger oils on there. Sweet. That looks good. Essentially, I just extended this by 2 extra grid locations so that we have a spot to connect our brace that we're working on. Okay, so let's do this side as the, we can probably just do this as an extrude with a draft and not even have to do a sketch. And let's do 3. Draft is the wrong way. Let's actually do 2.2. on this side, we can do the same thing, but we're going to make a new part, and this is going to be our stiffening rib. Let's do 1.6 on that. And we'll do a draft. Let's try 25. This is going to be a new part. Pretty tight, but you know, if we want to, we can kind of make these more tube-like. Fill out these corners, maybe. Not that much. I'm just going to kind of use a similar style as this here to hide that component. And we're gonna rough these out really quick, and so we can get some stuff printing. Let's isolate that. Let's do a new sketch. Let's go normal to. Let's go center line. And I believe those are 3. That's right, this is going to be tight. No, I don't know what the hell happened there. That might work with just 3. We might want more, but we'll try it with 3. See what happens. Extrude. Now add to this one. 2. We're going to draft 3. Let's do this. Let's change this draft to be a little less extreme. Maybe a little bit less. And we're going to do Boolean. It's our tool. Actually, first let's fill out those. Now we'll do our Boolean. Should have our snap holes now. Looks like they fit in there just barely. What is our distance here? It's pretty thin, isn't it? Could go a little bit wider on that if we wanted to. Jump into here, let's insert that part just to make sure everything clears, and then we'll go and model it flat and print it out. I guess in theory, can we do a revolute? Is it actually made up with this one, or is that gonna be impossible to solve? Cool. Well, it seems to kind of fit in there. First layer seems to be good. So I think I kind of like that. I think we'll round that off, but let's go design our flat one. I'm just going to go into, let's just throw it in the articulating bits. Let's derive those in. For reference. Didn't like those. It just wants me to bring them in here. Fine. Okay, so we're basically going to take this component and we're going to make a flat version of it. And so let's see, let's hide this for now. This one I think will be relatively easy. I think we can just kind of take it and transform it. We're going to rotate it. And the axis we're going to use is this one. But first, let's, of course it's a funky angle. Actually, I can probably get that angle here too. And copy that angle. Transform, rotate, axis. So in theory now we should be 180 degrees, so we should be able to then join that. And let's do the same thing here, although let's first move it. It's a little bit clunky, but that's what we're going to do. And transform this by XYZ. Actually, I wonder if we could just do it by make connectors. Let's try that. Boom. Okay. Now we should be able to rotate this axis, that amount, 180 degrees, and if we're lucky, we can boolean these into one part, not keep the tool. Look at that, one part. I think I kind of want to round this. Okay, so we should be able to, that should get us what we want. Let's export these, get these parts printing. Jump over to the slicer. Add this to our collection of new parts. Same with these. I don't know if I'll use these springs, those might get changed a little bit, but let's import these new bits. Let's split to objects. See 2 of those. Let's range them. Slice this up. Take a quick look. Looks pretty good. Let's print this. And then as soon as the, actually, we can probably, could probably go grab a plate and just print that on the other printer. Yeah, let me do that. I'm gonna get a little red accent in there, so hold on, I'll be right back. All right, I'm back. So we're, let's see, we've got a bunch of brace parts printing. So now we're gonna get some of these printing. We need 2 of them. Oops. Let's do a flow. Try that again. I just reconnected that printer, so looks like we're good now. Let's go back to the browser. Okay, so what we're doing is we're printing out a couple of these, and we're printing out a new tail section here that's got these outriggers, and essentially it should fold up into that. One of the things I'm curious about is how we can use a link pin connector out here, but what will we do to secure this? We don't have a lot of height. And could make a new sort of connector type, which is sort of like I guess you could call it a chassis cap that's got a snap out on one side and no snap. So we'll have to figure out kind of how to secure that bit, but that's essentially what that brace is going to look like. And there'll be one on this side obviously too. We've got those printing now. Let's see. And then we kind of modeled it up in this multi-part, so this 4-piece kind of approximation of the bent state. And then we brought it in here, and essentially so we brought in these components just into another studio, and then we just kind of basically transformed all the bits, and then we joined them into one part and just kind of cleaned some stuff up, and there we've got the flat printable part. So let's see, let's go back into this. I'm curious to see how this works out. I have high hopes. Let's see. Again, too, and we're with this tail section, because the wheelbase on this is shorter. We're actually going to mount this tire upside down because we have the clearance to do it. So that'll let us hang this tire weight out back, but also keep the center of gravity a little bit lower. And then I think, kind of because we're sort of using the Chenoweth Millennium buggy as a slight body design inspiration, I think we're going to put a little goofy little rear wing on this thing. So we'll see. We'll probably end up, or we will end up, to do that, we'll end up having to tweak this tail section a little bit more and obviously print some more, but that's okay. I just want to get this brace set up, tested. That was sort of the goal for today. So we've made a number of new components. We've made these two sort of extendo skid plates so that we can pick this up. I brought two out. We could probably do one, but I'm thinking of using like a double connector out down there just for a little bit of extra strength. But again, trying to figure out how do we cap that, because we don't have a lot of clearance kind of between that face and that. Couple millimeters. And the other thing we could do is we could build that into the TPU, but I don't like that. I think we're just going to make a little cap connector. We could probably do one that spans this whole kind of bottom section, and maybe gives us a little interesting feature here. So maybe we try that. So how many dots? That's 1, 2, 3, 4, 5. Is that right? Yep, 5. So let's just go ahead and do that. Let's so we're going to build a little. We need a way to capture these, and so we're going to build a little cap that spans this whole thing and has a little bit of a little neat detail, a little aesthetic detail, kind of where it passes in between and has that little reveal. So to do that, we are going to, you can see I don't think we've made a new connector, so let's just jump into the component generator. I have to refresh that one. So far the prints seem to be going well. And we're actually, this is going to be a connector. This is going to be a new kind of style, because so far all of the connectors have had snap studs on the other side. So we could probably use, I'm just worried that if we, I mean it, yeah, it's going to be tight. So that sort of span connector may or may not work, because I'll go to the overhead here. Let me just pop the springs off. So essentially we're going to have, it's kind of hard to see, but a little brace is going to connect here, essentially kind of like I can't pop it on there, but essentially like that. I'm just going to kind of go up to a tail section. And what we need to do is we need to cap that, but we need to cap it in a way that this brace right here doesn't hit when we're in full droop. Which is going to be really, really tight. mean, one alternative, I wonder if that would work. We could flip this brace upside down, which could be interesting. And that would buy, because it's not quite as deep this way as it is this way. That'd probably buy us like a millimeter, which might be all we need. Clearance is clearance, as they say. I don't know if that's better though. Let's operate on the assumption that we're going to mount this the normal way. So much of automotive stuff, especially race car stuff, is really just solving a packaging problem. Let's see, we got some parts done here. Little Coolio. So new tail section with the outriggers. That's why it's nice having multiple printers. You can kind of get a bunch of stuff going at once. So now we've got our little brace bits and our brace stiffeners. Okay, so let's put these together. Let's just kind of snap in there like that. Cool, let's do some snap dots here real quick. So that's a good question. I'm curious if our link pen is going to fit in there. Maybe. Just inserting these some snap dots so we can test this thing out. Okay, so let's for now we'll run it with the Mayday cab since the rough dimensions and the positioning on the grid will be the same. And then steal a little link pin. So it does seem to fit. And this will be the tricky part here. So that kind of goes there. Essentially. So that's essentially, it does look pretty cool. I do wish we could bring them inboard just a little bit, which, I don't know, there might be clearance, but I mean, there would definitely be clearance if we narrowed up this whole rear triangle link, but I don't know if we want to do that because it's nice having it be wide where it comes in. Because essentially we are straight in plane. It would have been cool if they kind of angled out, but I think the concept is sound. So now we just need to figure out a way of connecting these that doesn't interfere. That's going to be the challenge. That's such a tight space in there. We can't really bring it out to here because we've got that spring that's going to be there. Kind of roughly in that space. But I do think that kind of works, so we just need to figure out how are we going to connect that bit on the bottom. guess in theory, let's pull this apart here. We could bring that in there and there. That could be kind of cool. I almost wonder, doesn't quite stretch, but that looks kind of cool too. But I don't think we can make that work with the packaging. Although maybe. What if we, this might not work well at all, but let's try it. They're a little bit short for that. That actually looks kind of cool. Do we have? No, totally hits. Looks awesome though, but totally hits. But I wonder. I wonder if we went into the center there. Can probably replicate that a little bit, maybe. This might not be long enough though. And this won't snap together, but let's us try it at least. Even then it's still going to hit, so we've got a couple things to figure out here. You say we could bring those in like that. Again, this cab is going to be different, but all the connective dimensions are the same, so we can figure out this bracing. But that doesn't really help us with what I like most about the bracing, and that's that it helps keep the entire cab and tail section secure. So I do think we can sneak it in there. I think we're just going to have to get tricky with how we connect everything. So that all clears. Let's pop. So we need to be able to get this snap dot on there. We can limit the travel a little bit. So let's design a connector. That is just like the bare minimum height. So we're in the component generator, copied the clipboard. I'm going to go back into here. I'm just going to move a couple of our bits. Let's paste that tab. Okay, so we're going to make a new connector. We're going to make this one span 5. We can turn off the layout pattern, and we're going to go in and fix everything here. And in this case, we don't actually want any snaps, so that's going to be one strange element, which also means these two features can go away. I think we'll keep the peel flange. Let's see if we can get this done in the next 15 minutes. Should print fairly quickly. Okay, so I think let's go back to the snap dot. Extrude. Oh. I'm going to show all parts. And I only want to extrude 2 of these. So we're just going to delete. Oh. This one and this one. And so now I think what we kind of want to do is let's go to the translucent view. And I think we want to kind of trim out as much of that as we can so that we have clearance for kind of basically right where those 2 things, when that's in full droop, you know, we don't have much clearance there. So let's just do a quick sketch. Get a center line. Let's use that. Can we get closer? Maybe. Let's see, and that's probably 45. That should get us parallel. That probably is good. Let's see. Just trying to let's call that 2.5 or 2.6. Keep it in a multiple of layer height, and then let's mirror that. That's weird. I guess we didn't need to do that, but we do need to go the other direction. No. These parallel. They are. Better. Okay, let's just start with that. We'll clean that up. I just kind of generally want to get a sense of how well that works. Let's do a quick cross section. It gets pretty thin there, but let's see what happens when we slice it. $11 minutes. I think we can get this done. Let's do this on 0B. And let's just pop into the browser. Let's throw this in our assembly real quick. We're going to fasten this. That's about where it's going to sit. Oh, derp. So we're gonna be limiting droop with that. We'll throw it in and try it, but I'm not convinced that that's the way just yet. That's about where it'll be. Let's see, there's got to be is there another way or place that could come in? I guess we could do a bring it in right off the center. Oh, let's see what this actually limits. We've got, now we're bringing this brace kind of down into there, but we've got an issue where we don't have a lot of room to make a connector. I've got one printing, but I think it's going to be too much interference. It looks like that in the assembly. Could bring this into here, but again, it's not the greatest. We didn't even get to the wing today, but maybe tomorrow. Tomorrow we'll get this figured out, and then we'll move on to the wing, and then we'll move on to the cab probably, and then the hood, and then this thing will be pretty much ready to go. We'll print some out to test, but our only other real solution is we could bring this triangle link into the center. I've done some like that. It's not terrible, and especially because it's a slightly shorter wheelbase, shorter trailing arms. We could probably get away with that, whereas on this one, it's so far extended out that it's already, the aspect ratio of the triangle is already a lot longer than its base is wide. Whereas on this one it's a little bit better. So we could actually bring those 2 points in, and that might we might end up having to do that. So we'll see if between now and tomorrow morning I don't have a better idea. I think that's what we'll start with, which will let us use probably the connector we're printing out now. How much longer does that have? 2 minutes. So we'll stick around. We'll pull that that connector. So let's see, what's the best way? We'll just start thinking through kind of order of assembly on this too. My guess is you have something like this, probably this part would be disconnected. Get your braces on. We'll snap our, you know what though, that's not, that's not going to work. A couple things we need to do here. That's probably more what we want. I wonder if we can just get a little. A little bit dirty here, but basically just kind of trying to trim away everything we can on this to get a little more clearance. Doesn't quite get us there, but it's close. So let's just print it out anyway. TLC, I made a mistake. Wanted not chamfering that hole, but also didn't provide clearance for this extra bit, but that basically will snap on like that. We're gonna go a little tiny bit past time just to get this final part printed out. Again, I think we're gonna have to revise it a good bit, but I just kind of want to have it in hand so that I can be thinking about it between now and tomorrow. Let's go back to the slicer. We're getting a nice little collection of new parts here. Okay, so that should be going now. Alright, so just a quick recap while we wait for that part to print. We've essentially created a new tail section that has these outriggers to pick up these braces. And these braces were modeled originally in this kind of in position configuration, and then remodeled flat once we kind of knew what those dimensions were so that it can be printed. We've got those printed out. We extended these things so that we can pick up that brace, and now we're just trying to figure out how to capture it and not completely limit droop with this interference here. We're printing this out, this connector out right now just to try it, but I think it's going to be too much interference. What I might do is we might redesign this triangle brace to come in here and here, so just a little bit inboard, and that'll give us plenty of room right there to pick up the brace. I even wonder at that point if we could bump these inboard. That might actually let us bump those inboard, but we'll see. We'll figure that out tomorrow, but a lot of this is just chasing, it's a multivariable problem. One variable affects another, so you just kind of you have to commit and try something, see what kind of a corner that backs you into, and then move on from there. But I think we're close. So we've got a couple solutions. I think that at this length, that should still be plenty stiff. So I think bumping that triangle brace narrower will give us plenty of clearance to either, at that point it should definitely work as it is, but it might also then allow us to bump these outriggers here inboard to that position, and so we can kind of get a little bit of a double triangulation, which will be stronger or more rigid and will also, I think, look better. I don't think this looks bad, but I think we can improve on it. So let's see. Yeah, we've got about 10 minutes to go, and we can and at some point this got off. How do we do that? Let's show these mates. We'll just fix some stuff here while we wait. That's the one. That's better. Parts still printing, but we're almost there. But so far I'm pretty happy with how this is coming along. Excited to add the mini rear wing, and a couple of things we could do. Again, multi-variable, so let's hide this. So if this does get bumped in, we could bring that in. Nah, we'll just leave that. I do like these here. I'll probably do a version that's narrower tomorrow and just see how it feels. If it makes the side-to-side movement too loose, we'll just probably rethink how we do the braces. Trying to think if there's any other way of getting that clearance. Or connecting. I mean, if we can find a way to not have to go up to 5 millimeters to connect it with a snap dot, that could be another way. like. I wonder. So it's kind of roughly full droop. So we could probably connect here. So that's another option. We could basically pick up these two and then have a little thin tab that sort of extends out to basically just capture that. That actually might be an interesting way to go. I think I'll try that first, because if I can leave this as wide as possible, that's just from a structural sort of rigidity of axle location sense, that's ideal. But we'll try this piece here real quick, just for giggles, since we've been waiting for it. Okay, so the idea is that this looks kind of cool. But the other nice thing about picking up those two and then doing a retention cap is we can kind of offset it so we can get the full snap depth, which will be stronger. It's not terrible though, actually. It doesn't limit droop in the real model nearly as much as I was worried about. So I would actually say that's a workable solution as it is, but I think the idea we just came up with, where we pick up the two center bits the two center snaps and then come out with a little captive wing will be the way to go. But generally speaking, and those let's just, while we're at it, let's throw in our upside down spare tire. Very nice. Just barely clears, which is perfect. So it kind of tucks up right in front of that spare. That's actually quite pleasing. Awesome. Well, made a lot of progress, figured a bunch of stuff out, did a bunch of dumb little mistakes in CAD, but yeah, as always, thanks for watching, and just like every other day, Monday through Friday, 8 to noon Pacific time, we'll be here working on ClickRigs kits, and we're working on the TBRD01 trophy truck kit, be working on that one till it's done, and then we'll move on to something else. I've kind of been wanting to do a garbage truck, since those are, every kid loves a toy garbage truck and is enamored with garbage trucks, but I'd kind of like to do like a sort of a high performance off-road racing garbage truck. I mean, in my head right now I'm calling it the decarbage truck, so we'll see how that goes, but that'll probably be the next project after this one, I think. So anyway, thanks for watching, and see you tomorrow.